You are listening to Climate Now. I'm Katherine Gorman.
And I'm James Lawler.
So, James, one of the tropes that I think we see a lot in the public conversation, and maybe it's a cliche at this point around climate change, is that sort of terrible imagery of watching sea ice break off and crash into the sea. And it's just like so sort of dire and maybe like a little Wagnerian. So let's talk about that, like sea level rise.
Yeah, it's one of the aspects or dimensions of climate change that the public has connected with because it's so clear. Like a rising ocean does damage to coastal property and makes storm surges all the worse. So it's something that the public has really caught on to. But what's less well understood is how exactly those dynamics work. And the fact, for instance, that global average sea level is different from the effects that might happen on a local level, which is harder to understand. So there are all these interesting dimensions to the rising ocean that we have to explore and we have to understand better. And here to talk with us about it today is Dr. Bob Kopp, who is a climate scientist at Rutgers University, the director of Rutgers Institute of Earth, Ocean, and Atmospheric Sciences, and a director of the Climate Impact Lab. Bob, let's start with an easy question. How did you get to where you are today?
Well, I sort of ended up as a climate scientist by a rather long arc. I started out as an undergraduate wanting to study life on Mars. So I sort of did. I worked on Martian meteorites, and that got me interested in the history of life on Earth. When I finished my PhD, I sort of wanted to take my skill sets, sort of looking at the Earth as a system, and try to deal with what I thought was one of the most pressing societal and policy challenges of the day, which was climate change. So I started at Princeton working with Michael Oppenheimer, who's a great friend and mentor of mine, on sea level change. I spent the first 2 years of the Obama administration in the Department of Energy's Office of Climate Change Policy, working with a great team there and getting a lot of really interesting experience, both on sort of domestic regulatory policy and international clean energy cooperation. And then I got an opportunity to come back to academia in a position that had both a science component and a policy component. So I came to Rutgers in 2011, and I guess this will make this my 10th year here. One side of what I've been doing is sort of grew out of the work I did at the Department of Energy on the social cost of carbon. And so that was a collaboration with now the 3 other co-directors of the Climate Impact Lab. And we've been working on sort of tying the state-of-the-art in physical climate modeling to the state-of-the-art in sort of statistical econometric studies of how people respond to climate to improve estimates of climate damages. And then now our focus is on sort of the global social cost of carbon. So how do we put the social cost of carbon on a firm sort of empirical econometric basis?
You proposed a framework in a paper in 2014, and maybe there's more recent scholarship on this, but connecting global average sea level rise to local sea level rise. Can you describe this relationship?
Sure. First of all, I guess we should define our terms. So generally, when I'm talking about sea level, I'm talking about something that's formally called relative sea level, which is a difference in height between the land and the ocean. So relative sea level can go up if the sea surface goes up relative to the center of the Earth, or if the land falls. What's called global mean sea level or global average sea level is the average of relative sea level over the entire ocean. Let's look at New Jersey. So what are the factors that control sea level off the Jersey shore? So starting with sea surface height, right? Because we got both sea surface and land height, sinking of land and rising sea surface that contribute. So one, right, the expansion of water takes up heat, right? That'll raise the sea surface. 2, right, the heat might not go everywhere in the ocean like equally, right? So actually that sort of thermal part, or what we call thermosteric, can lead to different sea level rise in different places. And also in terms of affecting the height of the sea surface, changes in winds or ocean currents can move water around. And that also affects the height of the sea surface. So, right, if you had an average increase in winds blowing out of the east off the Jersey towards the Jersey Shore, right, that would lead to an increase in sea level on the Jersey Shore on average. So then there are factors that affect both the height of the sea surface and the height of the land. And those have to do with moving large amounts of mass around, right? To raise global average sea level by 1 millimeter requires melting 360 billion tons of ice, right? And right now, we are getting close to 2 millimeters per year of global average sea level rise from melting ice. So that's on the order of 700 billion tons of ice melting every year. So these are large masses. And when you move masses like that around, you affect the gravitational field of the Earth. So when you melt, say, ice in Greenland, it actually causes a sea level fall near Greenland because there used to be this gravitational attractor on Greenland, and it's gotten weaker. And so you get less than average global sea level rise as you move away from it. So we get in New Jersey, we get probably about half the global average sea level rise from Greenland melt. And then if you go far away, say out into the tropical Pacific, you get more than the global average, up to about 20% more. And then there's also things that just cause the land to sink. So groundwater withdrawal, does have this mass effect, but the largest effect is very local, where pumping water out of the land causes the land to sink.
What are the orders of magnitude on that particular change?
So it really depends on where you are. Well, so New Jersey is not a most extreme example of groundwater withdrawal, but we're probably talking about 7 or 8 tenths of a millimeter per year on average over the last several decades, out of a total of 4 to 5 millimeters per year. Or you go to Bangladesh, right? You can get order of 3 feet of sea level rise per 100 years or more just from groundwater or oil and gas pumping. So in places where this is a major factor, that can be a really large factor and dominates what you see.
Bob Kopp of Rutgers University. James, it's just such a far-reaching systemic issue, sea level rise. And like on such a level, I never thought about it changing or having an impact on the gravity of the planet. But of course, right? Like that's how systemic and fundamental these issues are. And in addition to that, he's also done amazing work on the social cost of carbon, which is one of the other super fundamental issues, and really one of the crucial ways that we can understand the impact of all of this on our lives.
Bob Kopp has really made a career focusing on understanding uncertainty and on quantifying uncertainty, as we've heard, both with respect to sea level rise, but also large scale and intricate interactions between the climate and the economy.
Yeah, precisely. And one of the issues that's really at the interface, the interplay of those two things, the economy and climate change, is the social cost of carbon. And he's also spent a lot of time working on that. And we got a chance to dig into that part of his work as well.
So I'm going to focus on not what's happening now, because I honestly don't know, and nobody knows what's happening right now because there's an active process to revisit this. But I'm going to focus on sort of as of 2016, and then we can talk a little bit about what the Trump administration did. I think it was 2007. There was a court case where the Bush administration was sued because they had issued, may have been a fuel economy rule, but some regulation, and not taken into account the benefits associated with reduced carbon dioxide emissions. And the court ruled that it was arbitrary and capricious for them not to factor into account the benefits of reduced climate change associated with their emissions. And so sort of 2008, in the last year of the Bush administration, the different agencies started taking various different approaches to estimating, what is the value to society of reducing carbon dioxide emissions by a ton, right? That's what the social cost of carbon is. It's the benefit to society of a small reduction of greenhouse gas emissions measured in terms of dollars per ton of CO2. In 2009, when the Obama administration came in, they said, okay, well, we actually need a standardized approach to this that's used consistently across agencies. And so they set forth a process, an interagency process, that turned to the scientific literature to develop the methods used. And so let's just say that the social cost of carbon is not purely a regulatory concept. It's a concept whose roots in the climate economics literature go back to the early 1990s. And outside of the carbon dioxide concept in particular, this work on sort of social cost of environmental pollution goes back to the 60s and 70s. There are these relatively simplified climate economic models called integrated assessment models. They are models that have some representation of how changes in emissions translate into changes in temperature, some representation of how changes in temperature translate to economic damages. And there are sort of three major models that the Obama administration used, DICE, PAGE, and FUND, that were rooted in the literature. So what you basically do with these models is you run a simulation. You say, okay, well, what is, under your baseline emissions in a population scenario, what is the economic growth trajectory? Okay, now we're going to add 1 ton of CO2 in a year, so let's say 2010 or 2020, and we're going to look at how the economy changes in response, the global economy changes in response to that extra ton of CO2. Then we're going to look at that difference. So the difference is the additional damage caused by that ton of CO2. And then we're going to do some economic magic known as discounting to turn this time series of future damages over the next several hundred years into a single number that we value today. And so the interagency working group took some scenarios from the literature, the energy modeling literature for growth and for economic and growth and emissions. They sort of used the models that were built in to these different climate economic models to represent climate change, but factored into account sort of a standardized uncertainty in how much changes in CO2 translate into temperature. There's some range of that. That's something known as climate sensitivity. And so the final Obama administration social cost of carbon, and I'd have to look it up exactly, but I think in current dollar values for a ton emitted in 2020 is around $50 a ton. The Trump administration basically saying we're going to turn up discounting a lot, so we're going to value the future less, and we're going to ignore any damages that are not directly happening in the United States. So we're going to assume that whatever losses to agriculture or to human health or whatever that happened in other parts of the world have zero effect on the United States. And those are both things that sort of contradict what the National Academies described as best practices, and that those two things sort of cut the social cost of carbon from roughly $50 a ton to roughly $3 a ton.
How should it be used? Because right now it's used in this sort of narrow use in terms of, determining the cost of a particular regulation, say, that's set by the federal government. But presumably the possible use of social cost of carbon could or should be much broader than that.
Yeah, so I want to, I don't know if before we get to that, if I can talk about how it's being, the things on the agenda for thinking about how to improve it. So first, one thing that the Biden administration can do potentially right away in May within their first 30 days is reconsider some of those discounting discussions. So they're certainly going to go back to using a global estimate. And, that's justified for a number of grounds, but including because it turns out that, other countries respond to U.S. action on climate, and the U.S. reducing its emissions catalyzes emissions reduction elsewhere. There's a strong argument to be made for lowering the discount rate, and there's a lot of complexities around the discount rate, but the basic thing to take away is that the discount rate currently used as a central value is about 3%. In the longer term, where the Climate Impact Lab has been focusing is on improving the damage estimates that go into these climate economic models, because there's been an explosion of research in terms of economic techniques and physical climate science that can support them, and big data approaches that now allow us to really use large global data sets to estimate things like how exposure to a hot day or a cold day affects human mortality in regions with different income and different climates. And so that vast body of research, which the Climate Impact Lab is working on, is really something that will help move the models underlying the social cost of carbon beyond the sort of early studies that were calibrated. They calibrated the models in the 1990s and 2000s really didn't have these tools available to them.
A higher discount rate implies a lower social cost of carbon because so just to clarify that, Trump administration raises the discount rate, thereby lowering the implied social cost of carbon. One question there, why should, the discount rate used for social cost of carbon have anything at all to do with the Treasury rate? And
perhaps it shouldn't. That is the practice that is most consistent with U.S. OMB guidance. It's not at all from first principles that clear that you should. And this is a real division between those who think the discount rate should be set using absorbed market behaviors and those who think it should be set based on some other grounds. Broadly, it probably should not be set at a constant value because, first will say there are two reasons why you discount the future. One is impatience. right? You just prefer something today to tomorrow. And there's a lot of reasonable argument that may not be justifiable on ethical grounds. The other is because you expect people in the future to be wealthier than they are today. One approach to discounting is to try to figure out sort of what that relationship between consumption, how much somebody can consume, how many resources they have, and the growth rate of consumption and the utility of it is, and use that to inform the discount rate. So that in that case, right, if you have a future where the economy is growing faster, you should have a higher discount rate. If you have a future where the economy is growing slower, you have a lower discount rate. If you have an investment, saying climate mitigation, more likely to be beneficial in a world where you're poorer than a world where you're richer and have more resources to adapt, then that would cause you to further lower the discount rate. But basically, so how strong that decrease in utility of $1 is as you grow wealthier depends upon that parameter. But that's the basic idea. Like, right, if we $100 of damage to us today, perhaps we should care more about that than $200 of damage to somebody in 220 years if they are more than twice as wealthy as we are. So that's the idea underlying this type of discounting. This is not the discounting used in regulatory analyses, which usually are not designed to look over multiple generations, right? This is this intergenerational effect is a distinctive characteristic of climate risk climate analysis. But that's the idea. The counter argument, and the reason why some people, why practice has been to use the treasury rates is, well, that's very hard to figure out what exactly these parameters should be set at. And the treasuries are responding at least to market actors' preferences, and they give you something. And whether what the market actors are doing is right, that's something that one can contest, but it's something. Right now, though, the 3% discount rate, and certainly the 7% discount rate, is inconsistent even with that sort of descriptive approach to discounting, where we just try to learn what the market is doing. So I think it's very reasonable to say, well, actually, what the market is doing is only slightly relevant, but it's something that requires less. The ethical judgment you have to make is that it's somewhat relevant. But then we can look at the market and see, well, the market would not be valuing this at 3%, so why are we valuing it at 3%?
Bob Kopp of Rutgers University. It's so fascinating to hear the breadth and the depth of the work that he's doing, and just really taking a clear look at fundamental ideas like risk and how we react to it, I think is so crucial for creating the plans that are going to be necessary to react to our changing world. It's fascinating.
And just an update, since this episode was recorded, the Biden administration did return to the Obama-era $51 per ton social cost of carbon and has called for the interagency working group to reassess that number, so it could go up. And they're working on that assessment at the Climate Impact Lab, where Bob is a director. Bob Kopp's work is definitely work to watch and to stay abreast of. You can read not only the work he's done on the past IPCC assessment report, but also his book on the economic risks of climate change.
Absolutely. And of course, stay tuned for the next IPCC report, which will prominently feature the work of Professor Kopp. Well, that is it for this episode of the podcast. You can head over to climatenow.com to check out other interviews, watch our videos, and sign up for our newsletter. And if you want to get in touch with us, maybe you've got an idea that Bob Kopp should look at next, email us at info@climatenow.com or tweet at us at WeAreClimateNow. We hope you'll join us for our next conversation.